Okay, this handout is designed to provide you practice on the problems that you missed on this quiz so that you can do better next time. So if you messed up on problem 1A, we'd like you then to watch the video and make corrections on the quiz problem. Then try the practice problem on your own, hit pause, and then after you've tried it, hit play, and you can see how you did on that. And do the same for the other, whatever other rows that you need to work on. Okay, if you missed problem 1A, then watch this part of the video so you can see how this problem is done. To begin with, we're going to treat this inequality as an equation. So pretend it's an equal, and then we're going to graph it just like we graphed lines. To begin with, you have the y-intercept. So what we want to do is plot that point. -7, 1, 2, 3, 4, 5, 6, 7. And then we're going to use slope, which is over 4 and then up 5, starting at our y-intercept. Over 4, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. There we go. You can do it again. And now we have our dots. Before we draw some sort of line, you need to look over here at the inequality. The inequality is not equal to. That means you cannot use the points that would be on this line. These points that would fall on the line are not solutions, so you can't draw the line. So what we do is we draw a dotted line as opposed to a solid line, because these points don't work. So this 0, -7 is not an actual solution. We just plotted it to help us graph the line. The next thing we need to do is we need to look at the inequality symbol, and we see that the y values are less than our line. That means we want to go to all the dots that are below. All of these ordered pairs that are down here, all these dots are less than our line. These are all solutions. Instead of drawing a billion gazillion dots, we just shade it in. And this is the graph of this inequality. That's what we want. So let's let you try one. If you will follow the same steps, slope-intercept form, draw the line, figure out if it's solid or dotted, and then whether you shade above or below. Hit pause, and then when you're done, hit play, and you can check your work. Okay, so for this problem, we're going to do the slope and the y-intercept. So it's 5, and then we're going to go over 2 and down 1. So we'll start at the 5, and then we go over 2 and down 1. Do it again, over 2, down 1. We see that we have an equal sign. That means all the dots here are solutions, and so we can go ahead and just draw a solid line. And finally, we see that this is greater than, which means we want to go above the line. That means all these points above the line are solutions, so we just shade above. And that is the graph for this inequality. We want to graph in problem 1b, if you missed that. We wanted to graph this inequality. It's not an equation, it's an inequality. We'd like to do slope-intercept form, but we need to get rid of that -3. So I'm going to divide everything by -3. This cancels the -3's there. And -9 divided by -3 is 3. And I'm going to leave this as a fraction because that will be our slope. The negative sign can go anywhere. I'm going to put it on top. You could have left it on the bottom. And then there's an x. Because we divided by a negative, the symbol has to change direction. And now we have slope-intercept form, and we can graph. I'm going to start at 3, and then I'm going to go over 3 and down 2 using slope. So we start at 3, 1, 2, 3, and then it says the slope says to go over 3 and down 2, over 3, down 2, over 3, down 2. Then we look at the inequality symbol, and we see that it's equal to, so we can draw a solid line, and then we see that it's less than, so we want to go below. So we're going to have a solid line, and then we want to shade below. All these points, all these ordered pairs down here are all solutions. So what we do is we just shade. Okay, so let's let you try a problem. You try to graph this one, hit pause, and when you're done, hit play so you can see how it's worked out. Okay, we want to get the y by itself. Two negatives make a positive. Because we divided by a negative, the symbol changes direction. Now we have our inequality. Now we can graph. Start at -5, and we're going to go over 2 and up 3. Start at -5, and we're going to go over 2 and up 3, over 2 and up 3. Now we have to look at the line, or the symbol. The symbol is, there's no equal to, so we're going to use a dotted line, and it's less than, so that means we're going to go below. Dotted, and then all these points below are solutions, so I just shade below, and we have our graph of this inequality. Okay, if you missed 2a, we want to work on this row. The key to doing word problems is placement of the numbers. Start with a total. Find a total and write that total by itself on one side. Then find the other numbers, and those typically will go on the other side. So we're going to have a 50 and a 75. Notice the variables. The variable here is X is the number of Visa gift cards. And the Visas are $50 each. So it's $50 each The West Farms is $75 each. We're going to add all that up together, and it has to be less than or equal to 600. Think about that. You can't spend more than 600 because all you have is your gift cards. You can spend 600, that's why it's equal, or it's going to be less than. Okay? So we want you now to try a problem on your own. So try this, hit pause, and when you're done, come back and check your work. Okay, start off with, I look for my total. I look for the parts, burgers, $3 each, $3 per burger. Hot dogs, $2 each, $2 per hot dog. We're going to add those together, and the most we can spend is 60, so it's 60 or less. If you need help with 2B, you missed that, then let's work on this row. I have the problem from part A written for you here. What we want to do is we want to graph using intercepts because it's in slope-intercept form. We don't have the y by itself. The way that you do intercepts is you plug in zeros. So we're going to plug in a 0 for x, and we're going to plug a 0 in for y. When you plug in a 0, 50 times 0 cancels, it goes away. 75 times 0 is 0, goes away. And now we simply solve what we have left. That's an easy solve problem. Two of them. Now we have our two intercepts. This intercept would be 12, and then we plugged in a 0 for y. This one we plugged a 0 in for x, and we found out what our y is. And now we can graph those. Zero, 8, and then 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we have to look at the inequality again. The inequality has an equal to, that means it's going to be a solid line, and it's less than, so we're going to go below. So we have a solid line, and we shade below. All of these ordered pairs below are solutions. We can't go down here into the negative region because you can't have negative cards. So we focus on just the first quadrant. And there you go. Each of these ordered pairs is a solution. Okay, let's let you try a problem. I have for you here, and you can copy this, I have the inequality that you're to graph. Try to graph this using the intercepts, hit pause, and when you're ready, come back and check your work. Okay, so we're going to write this equation twice, one for the x, one for the y. Intercepts. I'm going to plug in 0 for x, make that go away, plug a 0 for y, make that go away. And now I have my two, that's an x. Now I have my two ordered pairs. That's not going to quite fit on my graph, so I'm going to count by twos. and I see that I have 12, 14, 16, 18, 20 right here, 10, 20, and then 30 at the top up here. So my 2 points were 0, 30, and 20, 0. I see here in my equation that it could be equal to, and it's less than, so it's below. Equal to tells me it's a solid line, and then we're going to go below. We can't have negatives, so we're going to stay in the first quadrant. And there you go. Each of these ordered pairs are possible solutions. Okay, now if you need help with 2C because you missed that, you're going to explain what 7.1 means in the context of part 2A and 2B. So I have 2A and 2B written for you. Keep in mind that 7.1 is X and Y. Let's review what X and Y are. X is the number of Visa gift cards, and Y is the number of West Farms cards. So that's good. There's your X and Y. I'm going to write those down. So Y is the number of West Farm cards. X is the number of Visa cards. So if X is the number of Visa cards and X is 7, that means we have 7 Visa cards. And then Y is the number of West Farm cards, and that's a 1. So we have 1 West Farms card. And that's what we mean by what this point means. It's an ordered pair that represents X and Y. X and Y are Visa cards, number of Visa cards, number of West Farms cards. Okay, so let's let you try that. Same type of problem over here. Interpret what 5.4 means in this. If you will hit pause, try it, and then come back, hit play, and check your work. Okay, in this problem, X is the number of burgers. And that's what you have here, X. Y is the number of hot dogs, which is 4 in this problem. So that means we have 4 dogs, and you have 5 burgers. And so that point, 5.4, which would be right about here, that's what we're talking about. Okay, if you missed 2D, you want to do this row. I have 2C and 2B done for you because 2D refers back to those. They say, is it a solution? And by that they mean problem 7.1. So if you take a look, where is 7.1 located? 1, 2, 3, 4, 5, 6, 7, 1. Is it a solution? Well, there's 2 ways of talking about it. First, yes, it's in the shaded region. But another thing to keep in mind is that if you plugged in 7.1 into this inequality, replace the x with a 7, replace the y with a 1, you would get 350 plus 75. That is definitely less than 600, and so that works. So it's also a solution because you'd get 350 plus 75 is less than that $600. You didn't spend all your money. So there's two ways of addressing that. So let's let you try the same thing here. I have for you the inequality listed for you in case you don't have that, and I also have the ordered pair, the graph, and in fact I've already plotted the point for you. So go ahead and try this one and hit pause, and when you're done, come back and check. Okay, as I mentioned, you can see that 5, 4 is in the shaded region. So that's one reason why we know it's a solution. And the other thing that we know is that if we plug in 5 and 4 into our x and our y, we end up with 15 plus 2 times 4 is 8. That's 23. That's definitely less than 60. So it's also a solution because it works in our inequality. If you missed problem 2E, then you are to come up with two solutions on your own. Easy way of doing that is to go up to the graph. I see here 1, 1 is in the shaded region, so that's a solution. And then maybe, how about 3, 2? That's a solution. And it says in context, two solutions in context. Well, the context is how many cards do we have? So 3, 2 means we have 3 Visa cards and 2 West Farm cards. 1, 1, we have 1 West Farm card and 1 Visa card. So 1, 1 and 3, 2. One Visa card, 1 West Farms card, and same thing with 3, 2. 3 Visa cards and 2 West Farm cards. Okay, so you try that for this problem. I have all the information you need right here. You can just write your answer down. Find two solutions in context for the hot dog and burger problem. Hit pause, and when you're done, come back and check. Okay, I came up with 2 points. You could have 2 different points. You probably do. I wrote them in ordered pairs. Notice I chose points from the shaded region. And so 2, 6, and 10, 4. Again, keep in mind what this means. The 10 would be the number of burgers. The 4s would be the number of hot dogs. And that's what I have here. You should have something similar to that.